Hello, my name is Yunus. I'm a mathematician. I have decided to put some A-level stats lessons online on YouTube because I noticed that many A-level students are worrying about it. Even before they start, they just think it's too hard. I do understand that's something that many students lose marks in stats exam, but it's just because there are some stuff that they didn't know about, some exam techniques or something that they need to know before going into exam. So if you haven't seen the first lesson, chapter 1 basically was about data collection, go back please and watch it. Please subscribe and share this video with other students so that they can benefit from it. As I said before, I'm using Dr. Frost's PowerPoints. I edit them a little bit sometimes, and if I find any mistake, I correct it. Okay. So in this chapter, I'm going to split this chapter to two parts, so it will have two videos. This is we started with data collection last lesson. Today we are going to talk about measures of locations and spread, and then we move on to representation of that data and correlation and stuff like that. So those are specification and references. If you want to read them, pause the video and read them please. And that's what you need to know. Pause it by the end of this if you like to pause it and read them. If you have any questions, just write it in the comment. I will answer as soon as I can. This chapter overview is going to be like split. Basically, the chapter is about split to 4 parts. Talking about the mean, median, mode, quartiles, percentiles, and decals, variance and standard deviation, and last thing we are going to do in here is coding. I think that's something that all students, math level students, need to know at the start, because students start with basically algebra and sometimes starts at the same time, and they get confused sometimes when we're talking about variables or x's. I want to talk about, for example, if you think about this one, sigma x, which is the sum of x. If it was in algebra, it will be, for example, if x is equal to a value, like let's say x is equal to 2, it would make no sense to write sigma x. While in so in algebra, you will write sigma of a function, like sigma f of x. While in statistics, we can write sigma of x, and x would mean would be like in here we said an example, the everyone's height, if x is giving us the people's height, so we'll have sigma the sum of everyone's height. Okay, and x bar, so x with a line on top of it, it means that is the mean. Okay, you can pause and read the rest. We're going to talk about measures of locations and spread. Measures of locations are single values which describe a position of data set. Position, for example, maximum, minimum, quartile, percentiles, and decals. So in here we have some measures of central tendency, which are telling us like something to do with the center of data. For example, which we know we used before a lot, the mean, median, and mode. The other type of measures that we are going to discuss are measures of spread. Measures of spread are to do with how data is spread out. For example, the range, the interquartile range, standard deviation, and variance. Here, the mean of ungrouped data. If we have ungrouped data, we know how to find the mean. So sometimes in GCSE we call it the average, but we have here like so many. It's not just the mean, the average. So the other, the median is also a type of an average. That's why we say we not calling them averages. So we know how to do it. We need to add all the values and we divide by how many values we have. Now I just wanted to talk about the notation. So here we write sigma x divided by n, lowercase n. Lowercase n is the number of items. We have here 5 obviously, and sigma x, we add all those values. You need to be able to use a calculator. This is most students bought, this is in 2020. Most students that I have, they had most students that I have, I thought they have this class with, which is a nice calculator suitable for A-level. Some students upgrade to something like that, which also draw some graphs, but you don't have to have this one. I will put a video to show you how to use the calculator exactly, but those are the steps. So it's step by step what you need to do. Obviously, before you select one variable, you need to go to stats most. I think it's you go option 6 or set 6, something like that. Okay. Here on the side, all those values are not all, but like for example this one, the calculator will not give you this value, but it will give you n. In this case we know that n is 5 because there are 5 values. Will give you the mean, which is sigma x divided by n, or sum of x divided by n, which is the same as x bar, by the way, so this will have to be the same value. Will give you as well sigma x. It will give you this value and it will give you n as well. So this value and n, we need to put them in the exam when we find in the mean, because they will give you a mark for accuracy, and this mark you need to show that you worked out those. Okay, this one, if you want to calculate, for example, 3x bar plus 1, you can do that. Here, now we're going to talk about if we have ungrouped data, the mean of ungrouped data. Okay, so that is in here we have sigma fx. That's what I was talking about before when we were comparing the algebra variables to statistics. Here fx means f times x, the frequency times in this case the number of children. Okay, it does not mean a function of x. Okay, so in here we basically sigma fx is 4 times 0, add 3 times 1, add 9 times 2, add 2 times 3, which is 27, and divide by sigma f. Sigma f is the sum of f. You add all those numbers, and if we divide that by that, we get the mean. Okay, that's exam tip. That's what I said to you before. You need to write this number divide by this number, otherwise you will lose 1 mark for the accuracy. Okay. Okay, that's what we said before. That's just sigma fx, and so you can pause it and read it. I already said it before. If you want to use the calculator, or you should use the calculator to sometimes the frequency column is not already in your calculator. So what you need to do, you need to press shift setup, then you go down, you choose statistics, then you turn the frequency on, and I advise you to always leave it on, the frequency on, because even if they don't tell us what are the frequencies, it's automatic, it's just register it as 1 or the frequency if you don't fill them. Now grouped data. Okay, as I said, most of those stuff is like GCSE, but you need to use a calculator. A bit we haven't started really with new stuff, but it's just like how to use a calculator and some vocabulary and stuff like that. Okay, so here we don't know the exact value anymore in these cases. So what we assume each value is, so if we have 4 and we have here between 0 and 0.5, between 0.5 and 1.5, what we assume, we take the midpoint from each one. So here we'll have to have, for example, we'll have to have the x is, so it will be 4 times 0.25 add 20 times 0.7, yeah, 75 and stuff like that. Okay, so the notation is sigma fx divided by sigma f, and this you get in the calculator. Obviously in the calculator you cannot put that, you just take the midpoint. We know how to find out the midpoint, so you can add them and divide by 2. For example, 1.2 add 0.5, which is 1.7, and you divide by 2, which is 0.85, which is the midpoint, and all the others the same. So that's the value that you get using a calculator, and that's the mean. Question: why is our mean just an estimate? Because we assumed that the height of those bears are always like 4, are always the midpoint, like 0.25 and stuff like that, because we just assumed that. Okay. This is something for you to read. Okay, many exercise in here. That's just, please just pause it and do it. I do this exercise with my students just to get them used to the notation, to get used to using the calculator. We know how to do it. So the difference between grouped data and ungrouped data, when we're talking about the notation, this will be like sigma c divided by n. This one will be sigma fx divided by sigma f. Okay, just the notation. And this one we know is going to be sigma as well, sigma fx ft divided by sigma f. Okay, here it's x, so I need to change it to t, because here we're talking about t, not x. This is an exercise for you. You pause and you try to do it. The last question, the D question, write down the effect with this will have on the mean, the mode, and the median if one item change. Like here we say that Meryl collected another mushroom, like with different weight. This question is often given in exams, something like that. But once you read it, it makes sense. So write down the mode. The mode is the most common. You check what is the most common, which is 700. Calculate the mean. You add them and you divide by 1, 2, 3, 4 by 7. Find the median. You put them in order, and you know how to do it. Now, if we have another value 650, what effect will be? For example, you need to say, let's say for example the mode has changed or not. We can tell that the mode will not change because we don't have any other 650, and the mode will still be the same, the most common. The mean and the median, it depends if it's below 650 or above that. So once you work out what is the mean and the median, you can tell if it's go up or down. Those are the answers. The mean will increase. Why the mean will increase? Because previously it was 600. If we add a value 650, it will go above it. Obviously, the mode will remain unchanged. The median will decrease the median will decrease, okay, because before it was 700 and now we have another value like before it, so it will decrease. Below it will decrease. That's another example for you to practice using calculator. Obviously, please start using calculator and stats mode. Whenever I say calculator, I mean stats mode. The model class, we know what is it. That's the class with the most frequency. In this case, it's going to be 351 to 400. An estimate of the mean wage. We know how to do it. We need to find the midpoint of each one, and then you know how to do the rest. Pause it. Check your answer. Okay, those are other two examples. Yeah, here it's combined mean. Combined mean. What does it mean? For example, here we have an example for it, and anybody who's doing maths A level should be okay to do it. That's like year 7 question. But we have a combined mean basically. I would like you to try it, and once you'll check the answer, so pause the video. Okay, now you can see the answer and it's self-explanatory. So obviously we need to add them, and we divide by the total. 20 pupils who got that and 30 who got that, so the total is 50. And this example as well, pause it, check your answers. Okay, yeah, so that is something that some students are they mix up when we have listed data or unlisted data. So we need to know what is the position of the median and what is the median. Okay, the position is important as well. You'll find out later why. There is a rule that you can follow, but it's also makes sense if you think about this one. Like we have here 5 numbers. The position, what is the median? The median, because they are already put in order, the median is 7. Okay, and the position of it is 3. Here we have 4 values. The median, what is it going to be? It's going to be between 9 and 10, which is 9.5, and the position is second / third. In here, when we have listed data, that's very important. Listed data, we don't say a position 2.5. Okay, it's kind of 2.5, but we say between second and third. Okay, and the median, we take the midpoint, the mid number between those. Okay, that's self-explanatory. Now if we want to want to find a rule, so can you rule how to find the position of the median? So from here, from this example, the position of the median, what did we do? We find n. If you think about n, we always divide n by 2. Okay, so we divide n by 2. 5 divided by 2 is 2.5. If it's a decimal number, we round it up to 3. If it is a whole number, for example 4 divided by 2 is 2. If it's a whole number, we take this n divided by 2 and the number that's coming after it. For example, second and third. Here 10 divided by 2 is 5, so it's between 5 and 6. 7 divided by 2 is 3.5. We round it up, which is the 4th. That's a rule. Okay, this rule you need to remember it, and also the notation, the way how we write here. Position is important. We'll find out later why. And those are for listed data. Now for grouped data, it's similar. It's a bit different, but it's similar as well. So here what we do for the rule, so we find as well n divided by 2. So we find the number divided by 2, the total divided by 2. In here, what is the total? Is we have 7, others 10, 15, 17. So the n, small n, is 17 divided by 2, which is 8.5. And then if it's a decimal, we don't round it up. If it's a whole, we keep it as well. So it's a decimal here, so we add them, divide by 2, we get 8.5. So to find the median of group data, we find n divided by 2 always. Then we use linear interpolation. Okay, linear interpolation, I will put a special video for about it to show you how to find it. It's very easy. With my experience, I noticed that some students are they get confused with it in the start, but it's very easy. I'll just put a separate video about it, and hopefully everyone gets it. So again, in listed data, to find the position of the median, we divide n by 2, and then we round it up if it's decimal number. If it's a whole number, we take that number and the number after it. While if we have grouped data, after finding the n, we divide by 2. If it's a decimal, we don't round it. If it's a whole, we still keep it as a whole. We don't say it's between that number and the number after it. And to find the median, we use linear interpolation. Those are some example questions, just quick questions. So you just need to know, practice which one is, like here we said, which one is listed data, which one is grouped data. So we know this one is, for example, this pause it now. Okay, you've done it. So this one is listed data, listed data, listed data, listed data. So here what we do, we have n is 11, we divide by 2, which is 5.5. So if it's a decimal, we round it up, so position is going to be 6. Here 24, we divide by 2 again, always we divide the n by 2. Is 12, so it's a whole number, so it's going to be between 12 and 13. This is not the same as previously. So what we do, we add here the n. N is 17. We divide 17 by 2, and then we keep it. Whatever we have, we keep it. It's 8.5. Here the same. 10 divided by 2, which is 5. Here we have 30. N divided by 2 is 30. So it's between 30 and 31. Here 21 divided by 2, and then we keep it. Here 35 divided by 2, and we round it up because it's a decimal. Here we have 13 divided by 2, and here 18 divided by 2, which is 9, and we take the number between 9 and 10. Okay, we stop here. Next lesson, part 2 of this chapter is going to start from linear interpolation. I'm going to do a separate linear interpolation in between to just explain to you exactly why we use linear interpolation and how we use it. It's going to be like with paper and pen. Then we're going to complete this chapter in another video. Thank you for watching. Please share this video with your friends and other students, and subscribe. If you have any questions, please write a comment, and if you want the 100% sheet for this chapter, just let me know. I'm very happy to share it with you. 100% sheet is basically the knowledge that you need to know, the formulas and everything what you need to know about this chapter, all in a PDF format. Thank you. Bye bye.